This is page 4-11. In the second part of this section, we are going to work with vertical translations. The graph of the function y is equal to c plus f of x is translated vertically compared to the graph of y is equal to f of x. The translation is c units up if c is greater than 0, and absolute value of c units down if c is less than 0. Example 4, we're going to be graphing a cosine function with a vertical translation. The period of this function is 2 pi over b, and b in this case is 3, so this is 2 pi over 3. The amplitude is the absolute value of a, which is -2. That means the amplitude is 2, and this graph will be reflected across the x-axis because of that negative. And there is no phase shift because you see how there is no plus or minus with the x. There is a vertical translation, and I'll abbreviate that VT, and that is a +3, so that means that it'll be translated up by 3 units. Now, since there is no phase shift, we could graph a period going from 0 to 2 pi over 3. To find the other 3 key points, we take half of 2 pi over 3 is pi over 3, and then half of pi over 3 is pi over 6. We're going over pi over 6 for each of these intervals. We have 1 pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6 reduces to pi over 2, and then 4 pi over 6 is 2 pi over 3. If you're getting a little confused between how we're doing this problem and the other 3, we can still follow the same method. In taking the 3x, we know that this is between 0 and 2 pi, and when we divide every part by 3, we have x between 0 and 2 pi over 3. If you'd like to use that method every time, it will work whether or not there's a phase shift. The amplitude is 2, so we're going to go up 2 units and down 2 units. I'm going to graph this a few times before we get to the final graph. We have a cosine function. Remember, the cosine starts at the maximum, goes down to the minimum, and then back up. So let's do that here. We're going to start off at 0, 2, down to 0, -2, 0, and then +2. And I'll make this dotted. Next, I'm going to reflect it across the x-axis. So the x-intercepts stay the same, but instead of at 2, it'll be at -2. Instead of -2, it'll be at 2. Still making this dotted. And then to get the final graph, we need to translate it up by 3 units. So here our middle was at 0, at the line y equals 0. Our new middle is going to be at 3. So I'm going to draw a dotted line. The equation of that line is y is equal to 3. And what we're going to do is take this green graph that I just drew and shift all those points up by 3 units. I'll start off with the middle points. And we know that the amplitude is 2, so we're going 2 units down from 3, and then 2 units up from 3. Let me draw the graph. And then we're graphing this over 2 periods. We can use symmetry to graph another period of this. So I'm just taking the positive x values there and making them negative. And we'll continue the graph on. I plotted the 2 middle points first. We know it's going to be at -pi over 3, 5, and then -2 pi over 3, 1. And that is 2 periods of a cosine graph that has a vertical translation. If we go down to the bottom of page 4-11, we'll see some guidelines to follow for graphing sine and cosine functions and translations of them. I used a combination of two methods. If we go to method 1, we found an interval whose length is 1 period 2 pi over b by solving the 3-part inequality. And this is where we wrote the argument b times the quantity x minus d and an inequality between 0 and 2 pi, and then we would solve for x. In step 2, we divided the interval into 4 equal parts to obtain 5 key x values. And then we would evaluate the function of the 5 x values resulting from step 2. We found the maximum point, the minimum point, and the points that intersect the x-axis, or if there is a vertical translation, then it would be the line y is equal to whatever c is. Step 4, plot the points that we found in step 3 and join them in a sinusoidal curve having the amplitude, absolute value of a, and then we draw the graph over additional periods as needed. In the book, the author uses tables to come up with these values, whereas I just did this directly from the graphs. So we used method 1, but we also used method 2. In method 2, you graph either the sine or cosine function. You find the amplitude, so absolute value of a, and the period is 2 pi over b, and then you use the translations to graph. So the vertical translation is c units up if c is greater than 0, or absolute value of c units down if c is less than 0. And then the horizontal translation, which is also known as the phase shift, is d units to the right if d is greater than 0, or absolute value of d units to the left is if d is less than 0. Let's draw another graph. Example 5. We're going to be graphing a sine function that has both a phase shift and a vertical translation over 2 periods. I'm going to follow the same method as I did for all the other examples. The period is 2 pi over b, and for this problem, b is 4. So that reduces to pi over 2. The amplitude is the coefficient of sine, and that's the absolute value of 2, which is 2. The phase shift, we can find this by factoring out the 4. So we'd have x plus pi over 4, because if I distribute the 4, then I'll end up with pi. So the phase shift is pi over 4 to the left. We know this is to the left because there's a plus. It's x plus pi over 4. The vertical translation is 1 unit down. And this is because c is -1 and c is less than 0, so we know it's going to go down. To find the 5 key points, we're going to take the argument, which is 4x plus pi, which is between 0 and 2 pi, and solve for x. I'll start off by subtracting pi. So we have negative pi is less than or equal to 4x is less than or equal to pi. And then divide each part by 4. And we have negative pi over 4 is less than or equal to x, which is less than or equal to pi over 4. We can plot the first key point and the last key point. First one is negative pi over 4. The last one is pi over 4. Halfway between that is 0. And then halfway between 0 and pi over 4 is half of pi over 4, which is pi over 8. And then negative pi over 8 for the second key point. Next, let's look at the amplitude. That's 2. So the highest point would be 2, and the lowest would be -2. That's before the shifting. And just like before, I'm going to draw what we have so far. And this is a sine graph. So remember how sine goes up to the max, then down, and then back to the middle. And we'll do that here. Starting off at negative pi over 4, we'll be at 0. Then it goes up to 2 at negative pi over 8, down to 0, pi over 8 -2, and then pi over 4, 0. I'll make this dotted since this is not our final graph. So far we've worked with the period, the amplitude, and the phase shift, and now we need to translate it down by 1. So we have a new middle. I'm going to plot the x-intercepts where y is equal to -1, and then the amplitude is 2, so the highest point now will be at 1, and then the lowest point will be at -3. So this is our final graph. And we're asked to graph it over 2 periods, so I'll use the patterns to graph the rest. Each of these intervals is pi over 8 apart, so this is 1 pi over 8, 2 pi over 8. This will be 3 pi over 8. And then 4 pi over 8 is the same as pi over 2, if I reduce it. Using symmetry, we have -3 pi over 8 and -pi over 2. The function will be repeating to the right and to the left, so it's going to go up to the maximum at 1, 3 pi over 8, 1, and then down to the middle at pi over 2. It will go down to -3 at -3 pi over 8, and then back up to -1. And we've just graphed a sine function that had both a phase shift and a vertical translation. On page 4-13, we're going to be modeling the average monthly temperature in New Orleans with a sine function. You can see a table here that has real data, and then the data is graphed with a graphing calculator to the right of it. And we're just going to do part A since we're not using graphing calculators in this class. And for part A, we need to come up with a sine function. To do that, we have to find A, B, C, and D. Now remember that A is the amplitude. To find the amplitude, we're going to use the maximum and the minimum average monthly temperatures. So if we look at the table, do you see how the minimum is 53 and the maximum is 83? A is equal to the difference of those numbers divided by 2. We take 83 minus 53 and divide that by 2. Then we have 30 over 2, which is 15. So A is 15, and that's the distance from the middle to the maximum and the middle to the minimum. If we draw the middle, it would be somewhere around here. If we want to come up with an equation for that line, y is equal to c, we need to find c. So let's do that next. The average of the maximum and minimum temperatures is a good choice for C. The average C is equal to the maximum plus the minimum divided by 2. If we add those and then simplify, we get 68. Y equals 68 is the equation of a line that's along the middle of the graph. Because the temperatures repeat every 12 months, B can be found using the period, which is equal to 2 pi over B. We know that this repeats every 12 months, so we're going to replace the period with 12 and then solve for B. Can multiply both sides by B and then divide by 12. So then we have 2 pi over 12, which reduces to pi over 6. Do you remember how the sine function starts at the middle, and that would be at this point here? And that looks like it's the 4th point. If we start the sine function at that 4th point, then we'd have to let d be equal to 4. Now I'm ready to write the equation. F of x is equal to, replacing the a with 15, times sine of the quantity b, which is pi over 6, times the quantity x minus d, which is 4, and then outside of the brackets we have plus 68. So this is the model of the average monthly temperature in New Orleans.